this was prelim 2 paper, and let us see how we start this physics paper with question 1. The first question will be 15 marks MCQ. From the given figure, the moment of force about point P is, now where is point P? Here. Can you see this is point P here? What do you see here? Equal and opposite parallel forces, do you see? Hello? Yeah? So the moment of force will be either of the force, yeah? Moment of force will be what? Either of force. That is how much? 25 Newton multiplied by the couple arm. So it will be like about P means 0.05 meter plus this. No, one second. I can't see this properly. There are two dots over there for P. There is one dot here. This is it is 0.2 meter, right?
Yes, ma'am.
Now, even if you say that this is 0.2 minus 0.05, even if you say this, how much it will be, tell me? 0.15, correct? Are you understanding this part? So it will be this force into this distance, this force into this distance, or when you take 25 common into bracket, excuse me, you will get this, that is 0.2 meter. Understanding? So it will become 25 into 2 means 50. So 5.0 Newton meter. This 5.0, this one. So it is C. Understood what I'm saying? Understood, not understanding?
Understood.
Energy conversion, burning coal in a thermoelectric station. Thermoelectric station means heat into electricity, correct? Where is it? Understanding? Write it down. Then
Ma'am, why won't it be chemical energy? Because burning coal, right?
Thermoelectric. I am chemical into, it should be into electric energy, no?
Yes, ma'am.
So, can I have chemical into heat in that? Even if I burn the coal, I will start with heating it only, no? So heating into chemical into electrical, it should be, right?
Yes, ma'am. Sorry.
Okay, so this will be the most appropriate, yeah? Confusion
Yes,
gone? Confusion gone?
Yes, ma'am.
Okay. What do they say? For the given angle of incidence and a prism, the two light rays A and B of different colors, it is seen that delta A is greater than delta B. Now remember, your delta A thinking step is greater than delta B. Okay. Now delta and lambda, how are they connected? Inversely proportional, correct? Tell now. Delta and lambda, how are they connected? The angle of deviation is inversely proportional to the wavelength, right? So it will be like this. Yes or no? Not understanding.
Yes, ma'am. Understanding.
So this is correct. Now for the given angle of incidence, different colors, it is seen that delta A is greater than, so delta and mu, they are directly proportional, correct?
Yes, ma'am.
Okay, and so you understood this is the correct option. With respect to the given table, which substance will have highest critical angle with respect to air? So for the fourth part, they are saying highest IC. Okay, now your thinking step is your mu water is 1.33. All right, mu glass is 1.5, mu turpentine is 1.47, and mu diamond is 2.41. Okay, so now remember, like mu of diamond is greater than, which is the smallest? Mu water. So this is the max mu and this one is the minimum mu. All right, so mu is equal to 1 upon sine of critical angle. Do you remember this? Yes. Therefore, mu will be inversely proportional to 1 upon IC. Do you understand this part? Because sine increases as angle increases. Sine of 0 is 0 and sine of 90 is 1. As the angle increases, the sine also increases. So mu and critical angle, they are inversely proportional. So mu water has minimum refractive index, so the critical angle will be max. Understood? And mu diamond has got maximum refractive index, therefore critical angle will be minimum. What are they asking? Which one will have the highest critical value? Which one it will be? Water. Understood? And say away, since mu is minimum, therefore critical angle will be max. Understanding the thinking behind it. Now you can give yourself marks for this depending upon whether you would be able to do it on your own. If you can do it with my help, give yourself 0. So which means you will come to know which are the areas where you have to focus on during your self-study. The wire of 54 ohm resistance having 30 centimeter length is tripled on itself. So I have told you that if you are not able to do it mentally, you can show your R1 is 54 ohm, R2 we do not know, the length L1 is 30 centimeter and it is tripled on itself, so L2 becomes 10 centimeter and area of cross section is A. So when you triple on itself, A2 is going to become 3 times A.
3A.
Then you will say R1 upon R2 will be equal to L1 upon L2 into A2 upon A1. Now this you have to know because resistance is equal to rho into L upon A. You have to know this by heart. So directly proportional to length and inversely proportional to area of cross section. You understood this part, right? So 54 upon X is equal to 30 upon 10 into 3A upon A. So X is equal to, X comes here and 9 goes there. So 54 upon 9 means how much? Understanding. Understanding. Doubts?
No, ma'am. No, ma'am.
Read this. Read this.
A container has certain mass of ice at 0 degrees Celsius. It takes T1 seconds to melt completely at 0 degrees Celsius. It is then heated to 80 degrees Celsius in T2 seconds. Which of the following statement is true? Specific heat capacity of water equal to 4.2 joule per gram per Kelvin. Specific latent heat of fusion 336 joule per gram.
Now, before we come to this, see, it's all going to go over your head just now. You just read it, it's not going to make any sense to you, correct? So what you will do, you will show the thinking step. Okay? So, container has certain mass of ice at 0 degrees C. So we'll have ice at 0 degrees C. It is taking T1 seconds and it becomes water. Completely melt means it becomes this, and then we are heating it to make it water at 80 degrees C, and this takes T2 seconds. Alright, now this will be heat Q1 and this will be heat Q2, correct? How much will be your Q1? Q1 is going to be equal to MLF, correct? Hello? Which is equal to M into 336. Understanding those many joules. And Q2 will be equal to MC delta T, which will be M into 42 upon 10 multiplied by 80. So that will be M multiplied by 8 to 16. Again it is 336. Can you see that?
Yes, ma'am. We had done this question in another paper also.
So Q1 is equal to Q2 is equal to 336 M, no? Correct? So if you are supplying the heat, your time T1 will be the same as time T2. Understood now? So here it will be C and T1 equal to T2. Is it making sense to you? An object is placed in front of a diverging lens, means concave, at a distance equal to focal length of the lens. Now remember, this you'll have to visualize. This is the lens, I'll just call that as L, and this is the focal length. It is placed at focal length, so this is the object at focal length. Okay, the first ray goes this way and it diverges and it appears to be coming from principal focus. Second ray goes from the optical center and it travels undeviated like this, correct? Now can you see the image will be exactly midway, no? Because this is a rectangle and these are the diagonals of the rectangle, correct? So the image will be where? It will be at distance half the focal length. It is on the same side, it's on the same side, it's on the same side, not this, not the other side. At twice the focal length? No, half the focal length. Where is it half the focal length?
C, midpoint of the focal length.
Understood how to do this now? Understood the thinking that goes there? Then we come to this is easy. beta particle emitted. What happens to beta particle emitted? Your x a z becomes y a and z plus 1 and plus beta particle, correct? This is how it looks like. Number of nucleons remains the same, means this remains the same, is correct. Number of orbital electrons decreases by one. Orbital electrons are not affected at all. Number of nucleons decreases by one. A remains A, so no. Number of protons decreases by one. No, protons increases by one. So this also is wrong. Understood how to go with that? Say yes, ma'am.
Yes, ma'am.
Yes, ma'am. Assertion on changing the direction of flow of current through the straight conductor, the direction of the magnetic field around the conductor also is reversed, is correct, no? The direction of the flow of current is reversed. The direction of the magnetic field also will be reversed, right? So it is true. And what is the reason? The direction of magnetic field around the conductor can be given in accordance to the left hand thumb rule. Oh my goodness, it is right hand thumb rule, no? Huh?
Yes, ma'am.
Left hand Fleming's rule it is, but it is thumb rule is right hand thumb rule, right?
Yes, ma'am.
So which one? True and
false. D.
Magnification of the lens is plus 2.5. Now here this they play with this for such a, you know, lots of variety they can give you. M is equal to I upon O, which is equal to V upon U, equal to plus 2.5. Okay, now remember your object is always upright, means positive. Now this is plus, so image also has to be positive, means image is upright. So what does this mean? Sorry. Agreeable to you? If image is upright, means what does it mean? Therefore image is correct. What does 2.5 mean? 2.5 is greater than 1, therefore image correct. So I have virtual and magnified image. So will it be concave lens or convex lens? Where will I get virtual magnified image? In a magnifying glass? Will I get it in a magnifying glass? Not understanding. Understanding or not understanding?
Understanding, ma'am.
So what am I asking you? Which lens it is?
It is convex lens.
Very good. It is convex lens, right? Okay. And if it is convex lens, to get magnified image, where should be the object? Between
F and the optical center.
correct. So Lens is concave, you can't take. Concave, you can't take. So lens is convex, and u is less than f means within focal length or beyond focal length. Between f and o means what? Is it this or, sorry, is it this or is it this? Is it difficult to understand? Because nobody is talking.
It's A.
It's which one?
A.
Okay, why is it A?
Because the focal length will be greater, because the object is between F and optical center.
Yeah, F and optical center. So it will be less than the focal length, correct? Understanding, right? So this is your A. Understanding. The graph shows the correct variation of kinetic energy of an oscillating pendulum during one complete oscillation from the mean position A to extreme positions B and C. So they are telling you there is the mean position is A and extreme position are B and C. So here over here your potential energy is 0 and here potential energy is maximum, but then there's a variation of kinetic energy. So kinetic energy here will be maximum and here kinetic energy will be 0. Understanding? So it is coming from kinetic energy maximum to kinetic energy 0, and then it's going to that side. Understanding? So you are going to see from maximum to minimum. Where is maximum to minimum? They are saying this is kinetic energy, correct? The kinetic energy is here. So if you look at this point, this is telling me that the kinetic energy here is maximum. Then it is decreasing, it's becoming minimum. Understanding? Did you understand what I am saying? It is becoming minimum, then again it is increasing. Can you see that? Then again it's increasing.
But those points will show, like it is written CAB, that means at A it should be
1
maximum.
minute. 1 minute. Now, yeah, 1 second. They said mean position is A. So A is mean position. At mean position, at A it should be maximum here, right?
Yes, sir.
Yeah, so this is your maximum kinetic energy, and then it is going from maximum to minimum, correct? Now here what is this? K. So from C to this thing, from K to C also is going from maximum to minimum. Here there is only A to B, they are saying. At A, kinetic energy is maximum, and at it is decreasing and it's coming to B, and here it is increasing. So it is not this, but this over here, it is not showing you the displacement in the other direction. So this will be the correct one. This is only from A to B, no? They are saying from mean position A to extreme position B as well as C. So here it is going only from A to B, right? Understanding? So this will be the correct option. This one, I made a mistake. The kinetic energy here, A, is showing minimum. But this will be which one? If A is showing minimum energy, so it would be at a potential energy. So potential energy would be like this and kinetic energy would be like this. Understanding, right? The correct option from the examples of different class of lever. Correct option. Fishing rod class 3, bottle opener is class 2, lemon squeezer is class 2 and fire tongue is class 3. So fishing rod is the correct one. Okay, go over it. If you are finding this little confusing, you can revise this part. It's generally colder after the hailstorm than during or before the hailstorm because ice liberates heat energy. Low is specific, no, it has high specific latent heat of fusion. Ice absorbs heat energy. Ice has a high specific heat capacity, no. Water has high SHC. So this will be because ice is going to uh, cooler after the hailstorm because it is going to absorb heat energy after the hailstorm to melt, correct? Understanding? It's going to melt. When it melts, it is going to absorb heat from the surrounding. Look at this next one. Compare the wavelengths. They are going in the same speed and this is the displacement time graph. Wavelength for P, if this is your X, so lambda P is from here to here, that is 4, and lambda Q is from here to here, that is 2. So the wavelength of P is to Q is 4 is to 2, which means 2 is to 1. Come to the 15th one. Shows the magnetic needle just kept below the conductor AB, which is kept in the north-south direction. In which direction does the needle deflect when the key is closed? Now remember your snow rule. Everybody must know that when the current is going from south to north and the conductor is over the needle, means needle is underneath, then the north pole of the needle deflects where? To the west. So where is the current? This is positive, so it's going this way. It is going from north to south, correct? So if it is NSO, it will be east. Agreed? So if the current is going from B to A, then the north pole is going to turn east. So towards what it is? Where is east? It is going to go this way. Where is it? Which east? There is this east and this east. So it is northeast, no? Northeast. It won't go south, east, southeast. What is this? East, northeast and southeast. Southeast will be here. It is going to be, it is this way, so it will deflect like this, correct? So northeast it will be. Agreeable to you? So we finished our question number 1 and question number 2 onwards we will do next time. This was prelim 2 paper and let us see how we start this physics paper with question 1. The first question will be 15 marks MCQ. From the given figure, the moment of force about point P is, now where is point P? Here. Can you see this is point P here? What do you see here? Equal and opposite parallel forces, do you see? Hello? Yeah? So the moment of force will be either of the force. Yeah? Moment of force will be what? Either of force. That is how much? 25 Newton multiplied by the couple arm. So it will be like about P means 0.05 meter plus this. No, one second. Huh? I can't see this properly. There are two dots over there for P. There is one dot here. This is it is 0.2 meter, right?
Yes, ma'am.
Now, even if you say that this is zero point 0.2 minus 0.05, even if you say this, how much it will be, tell me? 0.15, correct? Are you understanding this part? So it will be this force into this distance, this force into this distance, or when you take 25 common into bracket, excuse me, you will get this, that is 0.2 meter. Understanding? So it will become 25 into 2 means 50. So 5.0 Newton meter. This 5.0, this one. So it is C. Understood what I'm saying? Understood, not understanding?
Understood.
Energy conversion, burning coal in a thermoelectric station. Thermoelectric station means heat into electricity, correct? Where is it? Understanding? Write it down. Then for
Ma'am, why won't it be chemical energy? Because burning coal, right?
thermoelectric, I am chemical into, it should be into electric energy, no?
Yes, ma'am.
So can I have chemical into heat in that? Even if I burn the coal, I will start with heating it only, no? So heating into chemical into electrical, it should be, right?
Yes, ma'am. Sorry.
Okay, so this will be the most appropriate, yeah? Confusion
Yes,
gone? Confusion gone?
yes, ma'am.
Okay. What do they say? For the given angle of incidence and a prism, the two light rays A and B of different colors, it is seen that delta A is greater than delta B. Now remember, your delta A thinking step is greater than delta B. Okay. Now delta and lambda, how are they connected? Inversely proportional, correct? Tell now. Delta and lambda, how are they connected? The angle of deviation is inversely proportional to the wavelength, right? So it will be like this. Yes or no? Not understanding.
Yes, ma'am. Understanding.
So this is correct. Now for the given angle of incidence, different colors, it is seen that delta A is greater than, so delta and mu, they are directly proportional, correct?
Yes, ma'am.
Okay, and so you understood, this is the correct option. With respect to the given table, which substance will have highest critical angle with respect to air? So for the fourth part, they are saying highest IC. Okay, now your thinking step is your mu water is 1.33. Alright, mu glass is 1.5, mu turpentine is 1.47, and mu diamond is 2.41. Okay, so now remember, like mu of diamond is greater than, which is the smallest? Mu water. So this is the max mu and this one is the minimum mu. All right, so mu is equal to 1 upon sine of critical angle. Do you remember this? Yes. Therefore, mu will be inversely proportional to 1 upon IC. Do you understand this part? Because sine increases as angle increases. Sine of 0 is 0 and sine of 90 is 1. As the angle increases, the sine also increases. So mu and critical angle, they are inversely proportional. So mu water has minimum refractive index, so the critical angle will be max. Understood? And mu diamond has got maximum refractive index, therefore critical angle will be minimum. What are they asking? Which one will have the highest critical value? Which one it will be? Water. Understood? And say over since mu is minimum, therefore critical angle will be max. Understanding the thinking behind it. Now you can give yourself marks for this depending upon whether you would be able to do it on your own. If you can do it with my help, give yourself 0. So which means you will come to know which are the areas where you have to focus on during your self-study. The wire of 54 ohm resistance having 30 centimeter length is tripled on itself. So I have told you that if you are not able to do it mentally, you can show your R1 is 54 ohm, R2 we do not know, the length L1 is 30 centimeter and it is tripled on itself, so L2 becomes 10 centimeter and area of cross section is A. So when you triple on itself, A2 is going to become 3 times
3A.
Then you will say R1 upon R2 will be equal to L1 upon L2 into A2 upon A1. Now this you have to know because resistance is equal to rho into L upon A. You have to know this by heart. So directly proportional to length and inversely proportional to area of cross section. You understood this part, right? So 54 upon X is equal to 30 upon 10 into 3A upon A. So X is equal to, X comes here and 9 goes there. So 54 upon 9 means how much? Understanding. Understanding. Doubts?
No, ma'am. No, ma'am.
Read this. Read this.
A container has certain mass of ice at 0 degrees Celsius. It takes T1 seconds to melt completely at 0 degrees Celsius. It is then heated to 80 degrees Celsius in T2 seconds. Which of the following statement is true? Specific heat capacity of water equal to 4.2 joule per gram per Kelvin. Specific latent heat of fusion 336 joule per gram.
Now before we come to this, see, it's all going to go over your head just now. You just read it, it's not going to make any sense to you, correct? So what you will do, you will show the thinking step. Okay? So, container has certain mass of ice at 0 degrees C. So we'll have ice at 0 degrees C. It is taking T1 seconds and it becomes water. Completely melt means it becomes this, and then we are heating it to make it water at 80 degrees C, and this takes T2 seconds. Alright, now this will be heat Q1 and this will be heat Q2, correct? How much will be your Q1? Q1 is going to be equal to MLF, correct? Hello? Which is equal to M into 336. Understanding those many joules. And Q2 will be equal to MC delta T, which will be M into 42 upon 10 multiplied by 80. So that will be M multiplied by 8 to 16. Again it is 336. Can you see that?
Yes, ma'am. We had done this question in another paper also.
So Q1 is equal to Q2 is equal to 336 M, no? Correct? So if you are supplying the heat, your time T1 will be the same as time T2. Understood now? So here it will be C and T1 equal to T2. Is it making sense to you? An object is placed in front of a diverging lens, means concave, at a distance equal to focal length of the lens. Now remember, this you'll have to visualize. This is the lens, I'll just call that as L, and this is the focal length. It is placed at focal length, so this is the object at focal length. Okay, the first ray goes this way and it diverges and it appears to be coming from principal focus. Second ray goes from the optical center and it travels undeviated like this, correct? Now can you see the image will be exactly midway, no? Because this is a rectangle and these are the diagonals of the rectangle, correct? So the image will be where it will be at distance half the focal length. It is on the same side, it's on the same side, it's on the same side, not this, not the other side. At twice the focal length? No, half the focal length. Where is it half the focal length?
C, midpoint of the focal length.
Understood how to do this now? Understood the thinking that goes there? Then we come to this is easy. Beta particle emitted. What happens to beta particle emitted? Your X, A, Z becomes Y, A and Z plus 1 and plus beta particle, correct? This is how it looks like. Number of nucleons remains the same, means this remains the same, is correct? Number of orbital electrons decreases by 1. Orbital electrons are not affected at all. Number of nucleons decreases by 1. A remains A, so no. Number of protons decreases by 1. No. Protons increases by 1. So this also is wrong. Understood how to go with that? Say yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Assertion on changing the direction of flow of current through the straight conductor, the direction of the magnetic field around the conductor also is reversed is correct. No? The direction of the flow of current is reversed. The direction of the magnetic field also will be reversed, right? So it is true. And what is the reason? The direction of magnetic field around the conductor can be given in accordance to the left hand thumb rule. Oh my goodness, it is right hand thumb rule, no? Huh?
Yes, ma'am.
Left hand Fleming's rule it is, but it is thumb rule is right hand thumb rule, right?
Yes, ma'am.
So which one? True and
false. D.
Magnification of the lens is plus 2.5. Now here they play with this for such a, lots of variety they can give you. M is equal to I upon O, which is equal to V upon U, equal to plus 2.5. Okay, now remember your object is always upright, means positive. Now this is plus, so image also has to be positive, means image is upright. So what does this mean? Sorry. Agreeable to you? If image is upright, means what does it mean? Therefore image is correct. What does 2.5 mean? 2.5 is greater than 1. Therefore image correct. So I have virtual and magnified image. So will it be concave lens or convex lens? Where will I get virtual magnified image? In a magnifying glass? Will I get it in a magnifying glass? Not understanding. Understanding or not understanding?
Understanding, ma'am.
So what am I asking you? Which lens it is?
It is convex lens.
Very good. It is convex lens, right? Okay. And if it is convex lens, to get magnified image, where should be the object? Between
F and the optical center.
correct. So lens is concave, you can't take, concave you can't take. So lens is convex and U is less than F means within focal length or beyond focal length. Between F and O means what? Is it this or sorry, is it this or is it this? Is it difficult to understand? Because nobody is talking.
It's A.
It's which one?
A.
Okay, why is it A?
Because the focal length will be greater because the object is between F and optical center.
Yeah, F and optical center. So it will be less than the focal length, correct? Understanding, right? So this is your A. Understanding. The graph shows the correct variation of kinetic energy of an oscillating pendulum during one complete oscillation from the mean position A to extreme positions B and C. So they are telling you there is the mean position is A and extreme position are B and C. So here over here your potential energy is 0 and here potential energy is maximum, but then there's a variation of kinetic energy, so kinetic energy here will be maximum and here kinetic energy will be 0. Understanding? So it is coming from kinetic energy maximum to kinetic energy 0 and then it's going to that side. Understanding? So you are going to see from maximum to minimum. Where is maximum to minimum? They are saying this is kinetic energy, correct? The kinetic energy is here. So if you look at this point, this is telling me that the kinetic energy here is maximum, then it is decreasing, it's becoming minimum. Understanding? Did you understand what I am saying? It is becoming minimum, then again it is increasing. Can you see that? Then again it's increasing.
But those points will show like it is written CAB. That means at A it should be
1
maximum.
minute. 1 minute. Now, yeah, 1 second. They said mean position is A. So A is mean position. At mean position, at A it should be maximum here, right?
Yes, sir.
Yeah, so this is your maximum kinetic energy, and then it is going from maximum to minimum, correct? Now here what is this? K. So from C to this thing, from K to C also is going from maximum to minimum. Here there is only A to B, they are saying. At A, kinetic energy is maximum and at it is decreasing and it's coming to B, and here it is increasing. So it is not this, but this over here, it is not showing you the displacement in the other direction. So this will be the correct one. This is only from A to B, no? They are saying from mean position A to extreme position B as well as C. So here it is going only from A to B, right? Understanding? So this will be the correct option. This one, I made a mistake. The kinetic energy here, A, is showing minimum. But this will be which one? If A is showing minimum energy, so it would be at A potential energy. So potential energy would be like this and kinetic energy would be like this. Understanding, right? The correct option from the examples of different class of lever. Correct option. Fishing rod class 3, bottle opener is class 2, lemon squeezer is class 2, and fire tongue is class 3. So fishing rod is the correct one. Okay, go over it. If you are finding this little confusing, you can revise this part. It's generally colder after the hailstorm than during or before the hailstorm because ice liberates heat energy. Low is specific, no, it has high specific latent heat of fusion. Ice absorbs heat energy. Ice has a high specific heat capacity, no. Water has high SHC. So this will be because ice is going to uh, cooler after the hailstorm because it is going to absorb heat energy after the hailstorm to melt, correct? Understanding? It's going to melt. When it melts, it is going to absorb heat from the surrounding. Look at this next one. Compare the wavelengths. They are going in the same speed, and this is the displacement time graph. Wavelength for P, if this is your X, so lambda P is from here to here, that is 4, and lambda Q is from here to here, that is 2. So the wavelength of P is to Q is 4 is to 2, which means 2 is to 1. Come to the 15th one. Shows the magnetic needle just kept below the conductor AB, which is kept in the north-south direction. In which direction does the needle deflect when the key is closed? Now remember your snow rule. Everybody must know that when the current is going from south to north and the conductor is over the needle, means needle is underneath, then the north pole of the needle deflects where? To the west. So where is the current? This is positive, so it's going this way. It is going from north to south, correct? So if it is NSO, it will be east. Agreed? So if the current is going from B to A, then the north pole is going to turn east. So towards what it is? Where is east? It is going to go this way. Where is it? Which east? There is this east and this east. So it is northeast, no? Northeast. It won't go south, east, southeast. What is this? East, northeast and southeast. Southeast will be here. It is going to be, it is this way, so it will deflect like this, correct? So northeast it will be. Agreeable to you? So we finished our question number 1, and question number 2 onwards we will do next time. Number 1, the refractive index of a medium A with respect to medium B is B mu A is 0.8. So question number 2, first part we will say B mu A, and that is 0.8. The ray is incident at an oblique angle from medium A to B. Will the ray bend towards the normal or away from the normal? Now they are saying this B mu A, do you know what it means? B is here and A is here, and the ray is coming this way. Did you understand? And it is 0.8 means it's going into rarer medium. Do you understand?
Yes, yes.
Okay, if this is, let us say, air, so air has mu air is equal to 1. Okay, y'all are writing this. And then mu B is 0.8. So this becomes what? The rarer medium, and this becomes what? The denser medium. Did you understand this part? Hello? So it should have gone like this, undeviated, but it will go this way. Agreed? Now they are saying that from A, so I'll just change the color here and I'll take a black. So from A, if it is going this way, it will go this way. So this ray should have gone this way, but it will turn towards the normal. Correct or no? So what will we write for this? You have to show this, and then you will say the ray turns towards the normal. Okay, now I'm changing back the color to red one as it travels from A into bracket mu equal to 1, okay, to B, which is, no, from A, which is 0.8 to here mu B, mu equal to 1. Okay, that is from rarer to denser. Okay, understanding? Hello?
Yes, ma'am.
Name the material of the prism required to obtain spectrum of radiation that has wavelength. So for B, you will say lambda equal to 8,000 angstrom to 10 to the power 7 angstrom units. For this, I have told you the diagram. What did I tell you? Rocket takes many Indians via USA to X, Y, and Z. Correct? And this is visible. So this is IR. So this is red. And this is UV. So this is violet. This is 8,000. So your IR becomes
10 to the power 7.
8,000 to 10 to the power 7 angstrom. So therefore they are infrared radiations. And this is your thinking step. So therefore it will be which prism? Is it rock salt or
Rock.
quartz?
Rock salt.
Therefore rock salt prism required. So infrared rock salt prism. These are the keywords. Understood how to write your answer. Sometimes they will ask you even here, give reason. Why do we use rock salt prism? Because rock salt prism does not absorb infrared radiations unlike glass prism. Okay, let's come to passenger sitting in the car are suddenly pushed to one side during the circular turn. Give the scientific reason. What will happen when they are suddenly pushed to one side? So in a circular turn, the passenger experiences which?
Centripetal force.
Experiences centripetal force, correct? Centripetal force, but and pushed to one side during this thing, but centripetal force, but also remember their motion is due to the centrifugal force, correct? Hello?
Yes, ma'am.
That is why they will suddenly will be pushed to one side, no? Correct or no? And the passengers are pushed to one side due to centrifugal force. Okay, now remember it is a fictitious force which explains the motion of the passengers. Understood?
Yes.
We come to the second one. Uniform meter rod of 5 meters length weighs 90 newtons, suspended horizontally by two vertical wires attached at 50 centimeters and 3.5 meters respectively from one end of the rod. So you'll have to show the diagram first, and it is going to be 0 meter here and 5 meter here, and it is suspended by two vertical wires attached at 50 centimeters. So there is a one wire here at 50 centimeter and another wire here which is 3.5 meter. From one end means from 0. Find the tension in each wire. Now you are told this one over here, from here. This is going to be the weight, which is how much? 90 Newton. They are saying find tension in each wire. Now this is actually very rarely asked, this type of question. This is, but since your teachers have asked, let us see how we do this. This is equal to 90 Newton. Now this is going to be here, tension means the reaction force it is. So you can say R1 here and this will be R2. Agreeable to you? Hello?
Yes.
Okay.
Yes, ma'am.
Now remember, this is going to have the moment. The moment due to R1 will be equal to R1 multiplied by how much? From here,
2 meters.
this is 2.5 meter. This will be the center of gravity.
Yes,
Okay,
ma'am.
so that will be 2.5 and 50 means 2 meters. So Newton meter, and this will be this way, so clockwise. Okay, so clockwise moment. Okay, and the moment due to R2 is going to be equal to R2 multiplied by, from here to here will be
1 meter.
1, so Newton meter, and this will be anti-clockwise. Agreeable? Now your two moments are going to be equal, so R1 into 2 will be equal to R2 into 1. Okay, and R1 plus R2 is going to be 90. Correct or no? So you will say, since R1 plus R2 is the total upward force, will be equal to 90, which is the total downward force. So I can say my R2 will be equal to 90 minus R1. So 2R1 will be equal to 90 minus R1 into 1. So 3R1 is equal to 90. So R1 will be equal to 30 Newton, and therefore R2 will be equal to 90 minus 30, which will be 60 Newton. Okay, so therefore tension in first wire equal to 30 Newton and second wire is 60 Newton. This is a little application based. Normally they don't ask you questions like this. In fact, never have they asked in the ICSE. But if it is asked by your school, we will answer it. Okay, let us come to the third part. Diagram shows two glass containers A and B containing water. Three tuning forks PQR, frequencies 180, 256 and 480 respectively are held one by one. So we will write P has 180 Hertz, Q has frequency 256 Hertz, and R has frequency 480 Hertz. It is observed that a loud sound is heard when the tubes with when the tubes with two tuning forks loud sound is heard with the tubes with two tuning forks. If tuning fork Q resonates with the container A, state with reason which tuning fork will resonate in glass container B. They are saying Q resonates with A, which means 256 Hertz resonates with A. So definitely they are saying that two of these are going to resonate with both of these tubs. So it also means that 256 resonates with A and B also. Agreed? If it's resonating with A, it's resonating with B also. Do you agree with me? Hello?
I don't understand.
See, they are saying that it is observed that a loud sound is heard from tubes with two tuning forks. So Q is resonating with A and there are two of them which will resonate, no? So if it's resonating with A, it will resonate with B also, right?
Ma'am, wouldn't it be it only is resonating with A and then the other frequency is resonating with B?
For that you have to see the multiples, no? Here you have to see the multiple. Okay, now 256 is 16 into 16, correct? And 480 is 16 into 5, correct? But what is 180? Is it 16? Now I can see 16 ka multiple. Can you see that? Hello? So is this 16 multiplied by how much it will be? Let us say x. So what will be your x? Your x will be equal to 180 upon 16. So 4, 4, 16, 4, 4, 16 and 4 5s. So can you see it is 11.25. Can you see that? Is it a multiple here? Is it a multiple of 16? Didn't understand. 256 and 480, they are multiples of 16. 180 is not. These two are. Understanding?
Yes, ma'am.
Yes, ma'am.
Okay, so when I looked at this, I said that this is 16 into something, 16 into something, this is 16 into a fraction. So P is not going to be a multiple. Understanding? So Q resonates with A. Now to begin with, if Q is resonating with A has uh, A has longer column, air column, correct? Hello. And B has shorter, right, shorter air column. Okay, shorter air column. Agreed? So with B, it will have to be larger frequency, no? So therefore B resonates with larger frequency. Do you agree with that?
Yes, ma'am.
Larger frequency. Now if Q is having 256 hertz, 180 is lesser.
Yes, ma'am.
So if it had to resonate with 180, the column should have been like this. It should have been longer if it had to resonate with 180.
Yes, ma'am. Because frequency is inversely proportional.
Correct. Absolutely.
Yes, ma'am. Understood.
Okay, understood. So resonating with B, so does it make sense now? This is the thinking part. It is observed, state with reason. So you will say, therefore, R will resonate with B, and right over here, since B has a smaller air column with higher natural frequency. Okay, higher natural frequency. And then you will say, since 480 hertz is greater than 256 hertz, therefore your frequency of 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 R will be greater than frequency of Q, and that is why. Leave it. Now, one advantage, one disadvantage of producing electricity by nuclear fusion reaction than fission reaction. This is the learning work you will do on your own. Then two bodies A and B have masses in the ratio 5:1. Kinetic energies are in the ratio this. Find the ratio of velocities. This is a very popular question. You will always make the two columns, and the two columns will have M1 equal to 5M and M2 equal to M. V1 and V2 and here you'll say KE1 is to KE2 is equal to 125 is to 9. What is the formula for kinetic energy? Half m1 v1 square is to, correct? We got half and half getting cancelled. 5m into v1 square is to m into v square equal to 125 is to 9. M got cancelled and we'll have v1 square upon v2 square is equal to 125 upon 9, and this 5 goes here, so it will be in the denominator. From here it's gone that side, so 5 ones and 5 25s, which will be 5 square upon 3 square. Therefore v1 upon v2 is equal to 5 upon 3. Okay, so you'll say therefore ratio of velocities is 5 is to 3. You must mention it as a ratio. Do not keep it like so. Okay, the next question, uranium 92 is giving you this barium, krypton and X neutrons. So what would be the value of X neutrons? Here you have to remember that this is 141 and here this is 92. And what are neutrons? Neutrons are, they are having unit mass and zero charge. So it will be X into bracket like this, you'll have to write after writing this. Understanding. And then you will say mass number is conserved. If mass number is conserved, then 235 is equal to, no, 235 plus is equal to 141. 1 minute, this is 141, this thing, barium, krypton and 3 neutrons होते हैं ना?
Ma'am, 2 neutrons.
No, look at the this thing.
Ma'am, 141 plus 92 is 233 and
That's not the point. Here you have to add one neutron ray. One neutron causes the imbalance. There is neutron here also. Remember, the fission reaction happens because uranium 231 absorbs one neutron.
Yes, ma'am.
So it is 235 plus 1 is equal to 141 plus 92 plus x. X into 1 means x. Now this will be 236 is equal to, here it is x plus 233. So x will be equal to 3. So 3 neutrons. Understanding? You will have to learn up these reactions of fission and fusion. Okay, 75% efficient block and tackle has 3 pulleys. So what you will say, number of pulleys, tell me what do we say, equal to number of strands
equal to velocity ratio
equal to 3. Okay, then A, they are saying efficiency equal to 75%.
Right.
Then VR is equal to 3. So MA equal to question mark. Our relation is efficiency is equal to
MA upon VR.
Very good. So 75 upon 100 is equal to MA upon 3. So this is 25 3s, 25 4s. So
9
MA
upon 4.
is equal to 9 upon 4.
9 upon 4.
That will be 4 2s and 1/4 means 2.25. Always write the answer in decimal, otherwise you will get 0. Okay. Then B, effort required. So you will say MA equal to load upon effort. So 9 upon 4. Don't use 2.25. It will be lengthy calculation. Load is how much? 1000 Newton upon effort. So effort comes this side. So 1000 multiplied by
4 upon 9. 4.44 Newton.
How is it? Okay. Question number 3A. Using two right-angled isosceles prisms, show how the ray can be deviated like this. Now can you see this is deviation through 90 and 90, and this is again 190. So you will have to have one prism like this and the other prism will be like this. But when you draw, it's going to be a little difficult. So first of all, get this first. Can you draw that? Then I'll tell you how to get the diagram so that you will get your full marks. To begin with, remember that from here to here, this is your 90 degrees deviation. So for 90 degrees deviation, I will have to show this way with the isosceles prism. Okay, so the isosceles prism means I'll have to take this side equal to this side. Now I think I have made a mistake here. When I take this line, it has to make 45 degrees with this. See here, this has to be 45 degrees. So you may not always get 45. So what you do is, I'll tell you one small trick. Okay, you draw this and take your ruler in such a way that you are take it in such a way that approximately this side will be equal to this side, and let it be approximately equal. Understanding what I have done?
That's good.
Okay, so this is going to be here. You will show this as 45 degrees, this as 45 degrees, and this is 90 degrees. So this is the first prism. Now I have to show 180 degrees. So I will have to show the base over here. The base of the prism will be like this. Okay, and I don't know whether you are able to understand what I'm doing here. I have to get this as 45 and this as 45, so that here it will be 90. In order to do that, can you see over here this part and this part? These parts should be equal. These should be isosceles Chota triangles, the small triangles should be isosceles. Did you see what I've done? Did you see what I've done? Okay. See here, this much distance and this much distance should be the same. Understanding? And this distance and this distance should be the same. Are you with me? If you do that, then you will have no problem with the isosceles prism. Now take these 2 points and did you see what I've done? Now from here, take exact like this and this is coming proper, but this didn't come proper. This one was not proper. Yeah, it's more or less ODR. Mistake. I can't see the exact endpoints. No? Okay. So this angle over here will be 45 degrees and this angle over here, this is going to be 45 degrees and this is going to be 90 degrees. Now make sure that this triangle is like this. Don't put a triangle like this. This will never look like 90 degrees. Can you see that? So be very careful. Understood what I've told?
Yes, ma'am.
Okay. So this is understandable. Now let us come to the second part. What are they telling us? This was for 2 marks. The fuse is rated at 15 ampere. Can it be used for this appliance? So you are going to write fuse rating is equal to 15 ampere. The power of the appliance is 5 kilowatt, means 5000 watts, and the PD is 200 volt. So the safe current, what is your safe current? Safe current will be equal to, show over here, power is equal to VI. Okay, so I will be equal to, comes V this side, so P upon V. So that will be 5000 watts upon 200 volts. How much is it coming to be? 25 ampere. Now safe current for its working is 25 ampere and the fuse is going to cut off at 15 ampere. Will the appliance work? So what you will say? That no, you cannot use 15 ampere fuse as the safe current for the working of appliance is 25 ampere, which is, put comma, which is more than 15 ampere. No, you cannot use because the safe current is 25 ampere.
Do we need to add that the fuse will break or no?
I think you could more than 15 ampere, and then you should say that the fuse will melt and cut off the supply at 15 ampere. Okay? Hello?
Yes. Yes, ma'am.
Given below is the electromagnet. Name the polarity at X and Y. For X and Y, quickly show this and show just, no, mistake. Show this and just show 2-3 turns, that's it. Okay, and this is your, what is this? And this is the taller and this is the rheostat. Okay, now the current is going this way. Show the arrows, and this side it is clockwise. Can you see that? So what you will say, X will be anti-clockwise, correct? It is going this way.
Anti-clockwise, therefore north.
Yeah, so right over there, north polarity, and right over there since and anti-clockwise current, and Y will be south, put ditto marks, and since clockwise current. Which rule have we used? Clock rule. Then we come to B part. Suggest a way by which the strength of electromagnet may be increased. So what you'll say, strength.
Ma'am, resistance of rheostat should be increased.
No. Oh, one way they are saying of the strength of, refer to the question, yes. Refer to the question means you can't change the number of turns and you can't change the cell. So strength of electromagnet can be increased by decreasing the current by increasing the resistance of the rheostat. If they tell you in general, how will you increase the?
By increasing the turns.
Number of turns, not increasing the turns. Okay, increasing the number of turns, or by increasing the, and the other one is by inserting soft iron core. So there are 3 ways by which you can normally increase the strength of the electromagnet, but this is referred in the question means take just the way this is and now you increase the strength of the electromagnet. Did you understand the difference? Yes? All of,
Ma'am, could you please show that again?
Arc then means?
Ma'am, could you please show that again?
It will be the other way around.
Yes, ma'am. Ma'am, it should be by decreasing the resistance and by increasing the current.
What did I do over here? Strength of the electromagnet can be increased by increasing the current. Sorry. Big time mistake I made, Ray. Increasing, and here it will be by decreasing the, sorry. Thank you. I don't know what I was thinking of. I was thinking of something else. Sorry, my apologies. Y'all understood, right? The magnetic strength can be increased by increasing the current. And how would you do that? By decreasing the resistance of the rheostat. Have you changed it?
Yes.
Yes, ma'am.
Yeah. Thank you so much for correcting. Once again, sorry. Now, two metallic blocks A and B of different metals having mass ratio 2:3 is given the same amount of heat. Their temperature rises by the same amount compared to specific heat capacities. Now, when they tell you the comparison, it's initially if you write here case 1 and case 2. Okay, this is your question 3, fourth subpart. You write your M1 as 2M, M2 as 3M. Same amount of heat and the temperature rises by same amount. So Q1 is equal to Q and Q2 also is equal to Q, and delta T1 is equal to delta T, and delta T2 also is equal to delta T because the temperature rise by the same amount, means delta T is the same. Now we say Q1 equal to Q2. So M1 C1 delta T1 will be equal to M2 C2 delta T2. Okay, right over there since same heat supplied. Okay, now for M1 you write 2M into C1 into delta T equal to 3M into C2 into delta T. Delta T gets cancelled, M gets cancelled. So we have C1 upon C2 is equal to 3 and 2 goes that side. Please be very careful because sometimes in a hurry you will write 2 upon 3. Be very careful. Okay, so you will say therefore compare means you have to say ratio. Ratio of their SHCs is equal to C1 is to C2, which is equal to 3 is to 2. And this should be adequate working for you to get your 2 marks. Fifth one, again for 2 marks, dual control switch used to light the bulb. Copy the diagram and complete the circuit so that the bulb is switched on. Now, as of now, you will quickly show this. This is going to be your B. This is going to be your A. And you will show like this. 2 boxes you will show like this with 3 rounds here and 3 rounds here, and this is connected and this is going here, and this is the filament of the bulb. This is connected and this is connected. Okay, now you want the bulb to be switched on. So you can show this way and show this is your live, this will be neutral, and show the current going this way, and then please show the bulb glowing. You cannot show a fused bulb over there. The bulb is switched on, so you have to show don't just show bald bulb like that. Mark the supply terminals A and B with L and N. So we already put this L and N. Can you see that? Yeah, so that finishes our section A. Question 4, first part. .5 meter long pin is placed normal to the principal axis of a converging lens of focal length 0.12 meter. The distance of the pin from the lens is 0.15 meter. Find the size and the nature of the image.
Converging lens is convex.
Correct. Now they are telling you height of pin. That will be equal to 1.5 meter. They are also telling you that the focal length is going to be 0.12 meter, and converging lens means your thinking step will tell you that the ray coming from infinity, they will converge and meet here. So this is going to be the principal focus and this is going to be the focal length. From here, if you go on the right, it is positive. If you go this side, it is negative, correct? So it is going to be plus. The distance of the pin from the lens means object distance, that is u, is equal to 0.15 meter. So it is going to be object here. So it's going to be negative. Find the size and nature. Come to the formula. Find size and nature. Now you cannot find the size till you know the image distance. So from F and U, you have to find V first.
1 upon F equal to 1 upon V.
1 upon F equal to
1 upon V minus 1 upon V.
So 1 upon F will be 1 upon 0.12 is equal to 1 upon V minus 1 upon minus 0.15. Now I know that this is a little time consuming, but please show the change in sign now here. And 1 upon V will be equal to, this goes that side. So 1 upon 0.12 minus 1 upon 0.15. Unfortunately, you will have to show the numbers as decimals. Now 15 and 12, the LCM is 60, correct?
Yes.
So I'm going to write here 0.60. Okay, I know 0.6 is the same as 60, but I'm going to write this so that it's easier for me to do the calculations. So 12 fives and here 15 fours. Understood? Although
Yes.
0.6 is also more accurate, but doesn't matter. This helps us in our calculations here. So 1 upon 0.60. So therefore, what is V? V is equal to 0.60 meter, which means I'm getting the image will be this side. So it will be real and inverted. Now they are talking about the size. So I'll have to use magnification equal to I upon O, which is equal to, tell me, what is the formula?
V upon E.
So we have the image is inverted, object is upright, so it will be plus, V is plus and U is minus. Minus how much? Correct? Now this will go once and this will go 4 times, correct? So I will be equal to, this is 0.15 multiplied by 4, but it is going to be positive here and negative here, so minus. It is going,
It's 1.5, not 0.15.
1.5 I wrote, no.
Ma'am, but when you multiplied, you made it 0.15.
In the next step.
Oh, here, no?
Yes.
Here, no?
Yes, ma'am.
Excuse me. Correct? 15 for 60, so it will be 6 minus 6 centimeter, yes? No, meter. Have they given meter? Meter. Meter. Okay, so now, therefore, height of image will be equal to 6 meter. Why did I not write minus? Because it's inverted, that's why. But height will be 6 meter. Understanding? And then nature. What will be the nature?
Real, inverted, and magnified.
Real, inverted. Also, it was 4 times magnified, no? And also, where it will be, see, focal length is here. Object distance is between F and 2F. Can you see that? This 0.15 and this. Where will the image be?
Beyond 2f1.
Yeah, magnified. Remember, the image is going to be the same size at 2F. Then magnified means it will be beyond 2F. Understanding?
Yes.
Is it making sense?
Yes, ma'am.
And
Yes.
this side it will be 2F2. Okay? Understood.
Yes, ma'am.
John claims to have obtained image twice the size of the object from a concave lens. Concave lens will give me virtual, you know,
And it will
and
give
diminished. So is he correct?
no.
No, he is wrong. The first line. Reason?
Concave.
Concave lens
Hmm.
always has the diminished.
Concave lens forms diminished, underline diminished, and virtual image always. Hence, he cannot obtain magnified image. In it. Okay? The diagram below. Ray P is traveling from denser to rarer, and it goes parallel to the interface as P dash. This is the interface. This one is the interface. It goes parallel to it, means like so. Copy the diagram, complete the drawing. Oh, traced by ray Q. P goes as P dash. Okay, so which is the incident angle of incidence here? You have
30
to show
degrees.
like this. And this is 60 degrees. So how much is this? This is 30 degrees from here to here. This is 30 degrees. Correct? P is going this way as P dash. Okay, so we will show this. So what you will say? Therefore, critical angle is how much? 90 degrees minus 60 degrees. How much is that? 30 degrees. Correct? Angle I for ray Q is going to be more than 30. It is this much, right? If from here to here is 30, this is more than 30 or less than 30?
Less than 30.
So it will go away from the normal like this. Okay, so this will be Q dash. Are you with me?
Yes.
So this was for your 4 marks. No, this is going to be your 1 mark. This is going to be your 1 mark here.
Ma'am, there's
Now B part, find the refractive index of denser medium with respect to the rarer medium. Now this, remember, is 90 degrees here. Okay, so refractive index, that is mu of denser medium is going to be equal to sine I upon sine R. Now using the principle of reversibility, if the ray had to go this way, then it would have emerged this, gone this way into the denser medium, correct? Then this becomes your angle of incidence and this becomes your angle of refraction. So it is going to be equal to sine 90 degrees upon sine 30 degrees. Okay? So that will be 1 upon sine of 30 degrees is like this, which is equal to 2. You could even say that mu is equal to 1 upon sine of, okay, but for mu this way it will be sine of IC is what? Can you see that? Hello?
Yes.
Sine of 30. Understood? Which is equal to 2. You could have done this way also. Hello?
Yes.
Did you understand?
Yes.
The two
Yes.
methods, both of them are right. Okay, so this will be the third mark. Define the phenomenon demonstrated by the incident ray if the angle of incidence is 60 degrees.
Total internal.
Angle of incidence 60 degrees means it's going to be more than, so what will you say? C will be if angle I equal to 60 degrees, then angle I will be greater than critical angle and therefore it will be total internal reflection. I think this mark will be, and then 1 mark will be to define it. You have to define that phenomenon. Do you know the definition by heart? If you do not know, write over there for homework. Question number 5. Atomic nucleus A has 36 proton, 136 neutrons. So A says no. Number of protons is 36. Number of neutrons is 136. Nucleus A emits alpha particle, gets transformed to B, and we want the composition of it. So let us just look at it.
Z is 30.
Therefore, A has atomic number equal to 36 and mass number how much?
172.
But I will write 136 plus 36. 36 gives me 72 too. So 172 is correct. Now A part. What is A part saying? A, which is 172. 172 36 is emitting which particle? Alpha particle. So alpha particle, and it becomes B. So this will reduce by 4, means 168, and this 36 will reduce by 2, means 34, plus helium-4 2. Agreeable to you? Therefore B has how many protons? 34 protons. Okay, and 168 minus 34 means 134 neutrons. They asked me for the composition of B. Nucleus B emits beta particle and transforms to C. So B is 16834 and it emits beta particle, becomes C. So 168 remains 168 and 34 becomes 35, because one neutron from the nucleus becomes proton, so one proton increases. Correct? Plus beta particle means 0 minus 1. Are you with me? What is the composition of nucleus C? So nucleus C has protons how many? Protons how many? 35. And neutrons how many?
168 minus 35.
Very good. How much is that?
133.
133. There were 134. One became proton, so 133 neutrons are remaining. Are they talking about C part also? How does the composition of C change with respect to the nucleus B in the periodic table? Your B was 34 here and C is 35 here. So what will you say? It is gone on the right by one place, right?
Yes, ma'am.
So what you will say? Nucleus C shifts where? One place
To the right.
To the right of B, nucleus B, in the periodic table. And just right over there in the same period. Okay. Now, the next one, draw the diagram. Complete the ray diagram to show the path of light, this, and you have to find out the angle through which the ray is deviated. Is it easy? This one is easy. What is it going to do? This is going to go this way, correct? You have drawn the diagram, then you show the normal, and you have to write the measures. This is 90, this is equilateral, so this is 60 degrees, this is 30 degrees, this is
not equilateral.
it is, oh no,
It is 70 degrees.
oh no, what did they say? This is A is 70 degrees. Oh my goodness, I forgot. So what is it showing over here? Isosceles prism. Isosceles prism. So what are you going to say about these?
55 degrees each.
So you'll have to write x and x here, and you will say for isosceles prism x plus 70 degrees. They've given it for 3 marks, right? You'll have to plus 70 degrees equal to 180 degrees. So 2x equal to 110, x equal to 55 degrees. So this is your 55 degrees. This angle becomes how much? 90 minus 55, which is how much? 35 degrees. And this angle becomes how much? 55 degrees. Now you will say at surface BC, angle I equal to 55 degrees greater than IC, correct? Critical angle is given as how much? 42 degrees, correct? Write into bracket IC equal to 42 degrees. I don't have place, you write. Okay, so therefore total internal reflection. Don't write TIR in the exam. So total internal reflection means it's going to be here. This will be 55 degrees. This will be 35 degrees. This will be 55 degrees. So this will be 90, and then it will go undeviated like this. Okay. Let us come to the next part.
Ma'am, the question is find the angle through which incident ray is deviated.
incident ray is deviated by how much? There is only A, now there is B is not there, right? So incident ray is deviated
250.
By how much?
55 plus 55.
It was going this way and it has
It will be 250.
see, incident ray, this was the incident ray like this, correct? The angle through which incident ray is deviated, so this will be the angle of deviation. If it was going this way and now it has turned this way. Understanding? Understanding?
Yes, ma'am.
How much is this angle over here? How much is this angle here? No?
180 degrees minus 55 plus 55 plus 35 degrees.
See here, this angle over here is 55, correct? Didn't understand. Correct?
Yes, ma'am.
Yes, ma'am.
This was 55. This was 35. So this becomes 35 vertically opposite. Correct?
Yes, ma'am.
Yes, ma'am.
This is 55. This is 55. This is 35.
Yes, ma'am. Thank you, ma'am.
70 degrees.
Okay. So it will be deviated by 35 degrees plus 35 degrees, which is equal to 70 degrees. Diver looks obliquely at an object AB in the air. Does the object appear taller, shorter? I think this was a repeat question. In the rarer medium, the object looks taller. So your question number 5, second part, A, object looks taller. Okay. B, show the path of two rays AC and AD starting from the tip of the object that travel towards the diver, and how does the position of the image depend upon the color of light. So you will have to show the diagram. When you show the diagram, you will have to show first this line and show the object. But from the object, you will have to show a reference line like this. Okay? Show the reference line like this. Don't show the eye of the diver. Drawn that?
Yes,
Now
ma'am.
at C, you will show dot 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 the normal. At D, you show dot 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 the normal. And whenever you show these angles should be nice and oblique. Don't show these lines like this. If you show them like this, it becomes difficult for you to make them get bent. The visible bending you cannot show. Okay, so now here See, if it is nice and oblique, then you can show the ray bending towards the normal and let it come from here, this point where on the reference line. I told you to draw the reference line. This part should be drawn dot dot dot, and the second will be like so. Have I joined them to the correct point? I can't see it. From here I should start. Okay. Now I have to make sure that this is like so. Okay. This should be dashed and the arrows should be shown this way and this way, and the eye of the diver should be shown like this. The eye should be perpendicular to this, okay? And eye of the diver. Anything extra that you see, just clean it. And this is going to be your A dash. This side will be the A dash. Understood, right? Now position of the image, which means now the shift over here. The shift is going to be connected with the lateral displacement also. And do you know that it is inversely proportional to the color or wavelength? Depends on the color. What will you write over there? The position of the image that is the shift depends no, inversely proportional. So what you will say, decreases with increase in wavelength. This will be easier for you to remember because inversely proportional. But then they say color. So increase in wavelength means I'm going towards red from violet. Correct or no? Increase in wavelength means what? I'm going from 4000 to 8000 angstrom unit. Correct?
Yes.
So decreases for red. So that is, it will be maximum for violet and minimum for red. Understand how to think.
Yes.
Question number 6. Diagram shows the object A which travels to various positions B, C, D, E. With reference to the diagram, answer the following. The object moves from A to D across the surface. The sum of its gravitational potential energy and kinetic energy. Now, sum means the total mechanical energy, right?
Yes.
So, what will you say? The sum of PE and KE remains, underline that, remains the same. And what law have you considered over here? By
Law.
Although they have not asked, the reason is by law of cons of energy means conservation of energy. What does our B part say? The object will have minimum gravitational potential energy where
B.
B.
B has min PE, and what is the reason? Since min height. Correct? The object's kinetic energy at C is less than its kinetic energy at
B.
B. Now A.
kinetic energy. Now remember here, potential energy here is max. Correct?
Yes.
So kinetic energy is going to be min. Correct? They say kinetic energy at point C is less than, now this one has PE minimum, and so KE will be maximum, correct?
Yes.
Have we shown the diagram like that? Very good. How will you understand and remember, Babu? Quickly you have to move your hand. So now tell me, this C is in between, no? So C will have less kinetic energy compared to B, but more kinetic energy compared to A. What did they say? C is kinetic energy is C less than B, it will be, no?
Yes.
So what you will write for the C part? KE at B, no, KE at C less than KE at B. See, all of these are thinking type of questions, aren't they?
Yes.
They are not really difficult, but the vessel of mass 195 gram contains 200 grams of water at 40 degrees. How much ice is needed to cool it to 5 degrees C? Okay.
We'll need to draw the table.
You'll need the draw. Yeah, you'll need to draw the table. So we have. Oh dear me, I don't have place. I'll have to start here. Substance, mass, SHC/SLHF means specific latent heat of fusion, then T1, then T2, then delta T. Okay, so we have the vessel, mass is 195 gram, contains water 200 gram. How much ice? So we have ice also, and we'll write x gram needed to cool it to 5 degrees C, means T2 is 5 degrees, 5 degrees, 5 degrees. Initial temperature of the vessel is 40 degrees C. Water is also 40 degrees C. And ice, when they give you, if they don't tell you the, oh, they told 0 degree C. If they don't mention that, it means it is melting ice. SHC of vessel is 0.4 joule per gram per Kelvin. Specific latent heat of fusion of ice is 336 joule per gram. SHC of water 4.2 joule per gram per Kelvin. Okay, now let us get some space. Let us get some space. Now, most important thing is to show the schematic diagram for ice. It's going to melt first, form water at, and then it is going to become water at 5 degrees. Most of you do not draw this, and then you write only MC delta T for this or MLF, and then you go for a toss. What formula will I use here for Q1?
MLF.
Which formula will I write for Q2?
MC delta T.
MC delta T.
Now remember, ice is going to melt, it's going to gain heat. So I'm going to say at equilibrium.
By principle of thermodynamics.
Very good. Put equal to sign in the middle of the page and you'll say heat
gained by ice
Yes.
will be equal to,
heat lost by vessel heat.
very good. Now write equal to below equal to. Make sure that you are writing this systematically so that your examiner can find the values properly. Okay?
Ma'am,
Huh.
ma'am, we haven't written the delta T.
Oh yeah, we have to still write, no? 35 degrees here, 35 degrees here, and 5 degrees here. Thank you. So it will be MLF plus MC delta T. And for the vessel, what you'll write? M1 C1 delta T1, and water will be M2 C2, but delta T will be the same. We have to find X means mass, so take M common and write LF plus C delta T. And here start substituting. M1 will be 195 into 4 upon 10 into 35. Put a bracket for this so that you don't get confused and even the examiner doesn't get confused. For water, 200 into 4.2 means 42 upon 10 into 35. Two twos, two fives, 5 ones, 5 sevens. So we have 195 into 2. 19 to 38. So 390 multiplied by 7. Okay. Plus here, are we getting reasonably good number here? 35 to 70. So 700. So 42 into 700. We'll have to add these, so you'll have to multiply these. Now here it is M into bracket 336 plus C means it has become water here. So 42 upon 10 multiplied by 5. So 5 ones, 5 twos, 2 ones, 2 21s. So you are having 357 M equal to. I think I could do the addition here.
Ma'am, for the first one it is 2730.
Okay,
plus
7963 carry 6, 7 3s 21. 2730, that's what you said, right?
Yes, ma'am.
And
Plus
this is 2 zeros here.
29400.
7 2s 14, and when you add, you will get, are you getting 32130?
Ma'am, you could have taken 35 common.
Where?
Ma'am, in M1
No, don't do that. Don't do that. At least when you do this, if this step is correct, you'll get marks. But in your 35 common and you goof up anywhere, na, then you'll lose marks. Keep this separate. Okay?
Yes.
32130. Even for maths, you should do the same thing, especially when they ask for total surface area and all, no? Keep each area different and then lastly add, so that you'll get your marks also. So M will be equal to 32130 divided by 357.
Goes 9 times.
9 times, I think 7 times also it goes, no? Is it going 7 times? Just see here.
No, ma'am, only 9. 357 nines are 3213, so it will be.
Oh, this is going 9 times. You directly did with this?
Yes, ma'am.
Okay, very good. So it is 90. Okay, so this will be what? Mass of ice. Was it good, bad, or ugly? Now, those who are not comfortable with this, write this question 3 times. You should know where was your thinking difficulty or understanding difficulty and do that question. So that way you are reinforcing your learning. Read this.
In a track event, starter B fires the gun. The finished judge A hears 2 gunshots. The first gunshot is heard after 1/3 of a second, and the second gunshot takes 3/5 of second to be heard by A. If the speed of sound in air is 300 meters per second, calculate the distance between the starter and the ball.
Now remember, everything is not the. You have to say the and the before the vowel and the before the consonant. You can't write only the. Okay? The distance, the wall. Okay? Like that. Don't say the here and the here also. So you will have to show the diagram. You will show like this. Show the wall. And show Mr. A here and B here. Okay? Show like this.
Yes, ma'am, done.
Okay, done. Now from here to here, just show the dotted line like that. And from here to here, let us call this as D1. Okay. And from here to here, let us call as D2.
Yes, miss.
Let us write V is equal to 300 meter per second. And A hears 2 gunshots. So first sound heard by A will be the direct sound. Do you agree with that? It is the direct sound. Therefore, your T1, which is 1/3 second, will help me to use the formula V is equal to D upon T, but it will be from here to here D2 upon T1. Did you understand this part?
Yes.
So D2 will be equal to V into T1 So 300 meter per second into 1/3 second. 3 is going how many times? So that is 100 meter. Okay.
Yes.
Now they want to know the distance between starter and the wall means d2 plus d1. Correct? So let us now talk about the second sound. The second sound heard by A will be equal to the echo. Do you agree with that?
Yes, ma'am.
And then we'll say V is equal to total distance upon the time taken. And the time taken will be the second time T1 we finished here, so it will be T2. What do they say? Second shot takes 3/5 of the second to be heard by A. Sometimes they will say 3/5 second after the first sound was heard. Did you understand?
Yes.
If they say after the first sound, then T2 will be this plus this. But they are telling you that the second gunshot was heard 3/5 of the second, means T2 is 3/5. Okay. Now what is the total distance? He fired the shot from here. So the distance was this way and then back again here. Did you see that? So what is the total distance? Tell me.
100 plus.
No. First write D1 plus, D2 plus D1 plus D1. Did you understand? Do not substitute just now. Okay, keep it like so. Understanding. And then you are going to say this is D2 plus 2D1. D2 plus 2D1 is equal to V into T2. We already know how much is D2. Now substitute, okay? Don't substitute here only. So this will be your 2D1 is equal to 300 multiplied by how much? 3/5. 5 goes how many times? 60 times. So 2D1 is equal to 180 and then 100 goes that side. That will give us 80 and D1 will be 80 upon 2. So D1 is equal to 40 meter. Then what are they saying? Distance between starter means B and wall is actually D1 plus D2, which is 40 plus 100, which is 140 meters. Okay? State the path of refracted ray inside the prism when the light suffers minimum deviation. That now refracted ray. What does refracted ray mean? Your thinking step is like this. This is your incident ray, refracted ray, and emergent ray here. So remember, when it is minimum deviation, this angle, if it is minimum deviation, then refracted ray is parallel to the, so question 7(1)(a), refracted ray, we'll write it in short, refracted ray is parallel, underline the word parallel, to the base of prism. Okay, B. The angle of deviation produced by an equilateral prism is 25 degrees at an angle of incidence 36 degrees. So for B, we will write delta is 25 degrees. Angle of incidence means angle I is equal to 36 degrees, for which angle of incidence equal angle of deviation is produced. Now you didn't understand the question, so let me just explain it to you. If you look at the delta against I graph, show that this is the origin. Now for the given delta, if this is 25, then this one is your I1 and this one is your I2. Okay, which means for this angle of incidence also it will be 25, and for this angle of incidence also delta will be 25 degrees. Did you understand up to there?
Yes.
Yes.
So they are telling you if, and now remember your formula is your A plus delta is equal to I1 plus I2, correct?
Yes, ma'am.
So A is going to be 60 degrees since equilateral prism is equal to I1 is 36 degrees and I2 I do not know, and right over there since equiprism means equilateral prism. So how much will be I2? I2 will be 85 degrees minus 36 degrees. Okay, so 85 minus 30 is 55. 55 minus 6 is 49 degrees. Okay, did you understand this? So if this is 36 degrees, this one is going to be 49 degrees. All right.
Yes.
So if this is the angle of incidence, this will be angle of emergence, and if this is the angle of incidence, this will be angle of emergence. Do you agree with that?
Yes, ma'am.
Yes, ma'am.
Some of you didn't understand. See, we are getting your I1 as 36 degrees and I2 is equal to 49 degrees. So this means this is your angle of incidence and this one is your angle of emergence. So by reversibility of light, if this becomes the angle of incidence, then this will become your angle of emergence. These values get interchanged. Did you understand?
Yes,
but for
ma'am.
both of them, my delta will be the same. For each delta you have, if you take for this delta, you will have just, can you remove this? It's shining. It's the glare is
Yes,
coming
ma'am.
in my eyes. So for this delta, there are two values of angle of incidences. So one becomes the angle of incidence, the other becomes the angle of emergence. Understanding?
Yes, ma'am.
Yeah. So now they are saying if the angle of deviation produced by the equilateral prism is 25 and angle of incidence is 36 degrees, then for which other angle of incidence equal angle of deviation means 25 degrees will be deviation. That means 25 degrees deviation will be for which two angles? Did you understand? One angle is 36 degrees and the other one we found as 49 degrees. Did you understand this?
Yes.
So
Yes,
here
ma'am.
you got 49. So therefore the other angle of incidence equal to 49 degrees. Okay, now this was your thinking that I explained. So this was a good question. Some of you found it a little challenging. So go through it 3 times so you come to know how to think for different cases like this. There's a stringed instrument. 5 strings are there, A, B, C, D, E.
Yes.
Which string produces lowest frequency? Okay, now your here thickness is different, right? Thickness means area of cross section, correct? So frequency of the stringed instrument, your thinking step is proportional to root of 1 upon L, proportional to root of area of, sorry,
A square.
sorry, F is inversely proportional to the length, inversely proportional to the area of cross section, and directly proportional to the root of tension.
Yes.
Now this is what we have to think. Area of cross section, if it is big, that means it is thicker wire. And the area of cross section is less, which means it is thinner wire. Did you understand this?
Yes, ma'am.
So they are saying that lowest frequency means frequency low, so area must be more,
Yes, ma'am.
inversely proportional.
Yes.
That means the wire should be thicker.
Thin.
Which one?
A.
Sorry, ma'am. Sorry. Lowest.
Thicker
Yes,
means
ma'am.
E. So you will say E right over there, since it has a more area of
Cross section.
cross section. I'm writing CS cross section and put comma and say frequency inversely proportional to A. Let's come to B. Mention one way in which you can change the pitch of the sound produced by one of the strings. Now for one of the strings, the length is the same, area of cross section is the same, so I am going to change the tension. So how can I change the pitch?
Increasing the
So,
tension.
what you'll say, by increasing, no, by
By
changing, not increasing. They are saying changing the pitch, no?
Yes, ma'am.
So I can't say increasing, because what happens if you decrease, yes, the pitch will change also, correct?
By changing
If they say increasing the pitch, then you'll say increasing tension. If they say decreasing the pitch, you'll say decreasing the tension.
Yes.
But if they say changing the pitch, what you'll say, by?
Changing the frequency.
No. By changing. By changing what?
Tension.
The tension of that wire. That wire. And what you'll write into bracket? Frequency directly proportional to root of tension. Okay, we come to now the C part. The stringed instruments are provided with hollow sound box. Give reason. Now here you are going to consult the text and you are going to learn it by heart. Okay, learn it by heart and you are going to write it. For this you have to also take about the two things. What is it?
The
Large surface area, just write over there large SA, and the second one is resonance, resonating vibrations. So remember, it is so constructed that the frequency of the air column is equal to the frequency of the string. Okay, so there are two things that have to be included in that.
Yes.
We come to the third part. Third part, A part. Draw neat label diagram, velocity ratio 4. So VR is equal to 4, which is equal to number of strands equal to number of pulleys. Okay, now when they say neat label diagram, mention over here, therefore, number of pulleys in upper block.
2.
Yeah, equal to 2, and put ditto marks. Just write over there lower, put ditto marks and write over there 2. Now when you are drawing, remember this should be shown this way and labeled. What should be labeled? Rigid surface. Then you will show a hook, and then you will show one big one and one small one like this. Show the hook. Then you will keep approximately 1 or 2 centimeters and show another hook and the small one and the big one like this. Then you'll show the hook, and when you show the load, from the center of gravity you should show the arrow down and then label that as load. Don't just say L. Okay, and then you will show this way, you will go backwards this way. You can use the ruler and do that. Just I don't have a ruler, so I'm getting kind of very loose string over here. Can you see here it is tied? So you have 1 2 3 4, so load is equal to 4t. This will be effort. Don't just write E. And effort is equal to 1t, so effort is equal to t. Write everywhere t like this, and just make sure that these strings are not touching each other, and this string which is tied here, it is away from this hook. Don't let it touch both the hooks. Understanding? When you are showing the pulley, don't show the hook itta bada like this. Understanding? The hook should be shown a chota hook. Did you understand the difference here? If the hook is bigger, then the other hook will become too close to it, and then it will be an impractical representation of the system. Then you show this and you show this. What will you write here? Upper block. What will you write here? Lower block. Did you understand?
Yes.
And even if they don't mention, just write over there MA equal to L upon E. That will be equal to 4T equal to T, and that is equal to 4. Just mention this in one corner. You can show it even this, but I don't here, but I don't have space. Okay. What will be its velocity ratio if the weight of the movable block is doubled? Now velocity ratio remains constant and mechanical advantage changes, correct or no?
Yes, ma'am.
If the movable block is doubled, efficiency is going to become lesser, because the more will be the load, correct or no? So the useful load is going to be lesser. All right, so mechanical advantage is going to decrease. Okay, part of the energy is going to be used in moving the movable block. Efficiency will be lesser, but velocity ratio, what you'll say? Velocity ratio remains
Same.
Constant.
Hmm.
Remains same.
or constant. Okay, what will be the effect? It remains the same, that is VR equal to 4. Then if you want to know, right over there, since VR does not get affected by any factor. Remember, velocity ratio is the ratio of displacement of the load and effort, so that remains the same. What change can be made in a movable pulley to increase the efficiency?
Reducing the friction.
No, it's a movable block. No, the first thing will be to increase efficiency. If any time there is a block and tackle system or there is a movable pulley involved, to increase the efficiency, number one thing will be to decrease the weight of lower block. Okay, this is the number one method. Okay, and the second one will be to increase this thing, to increase the efficiency, not to lubricate the system to reduce the friction. Between the bearings and the rope and the pulley, correct?
Yes, ma'am.
Just put dot 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 so you can complete that statement. Question number 8. The power circuit uses the cable having 3 different wires. Which wire in the power circuit, what is this? Poses as potential danger if touched.
Live.
So live wire. Between which of the wires should the heating element of the geyser be connected? No.
Neutral, because
Between-
earth is the
Between
Live
which
and
of the wires should be heating element connected? Live and neutral, no?
Yes, ma'am.
Live and neutral.
Casing is in the
Huh. Casing means earth, correct or no?
yes, ma'am.
Huh. Between to which should the metallic case be connected? Now remember, they can ask you why also. Okay, and then you should be able to learn those reasons by heart. We come to the third part. What is the third part saying? Copy and complete the following nuclear reaction by identifying X.
Electron.
So we have C is 14,6 becomes nitrogen 14,7 plus X. So it is going to be AZ becoming AZ plus 1 means X is a beta particle. They are saying copy and complete the reaction. So this will be, in place of this, what you'll write? Beta 0 minus 1. Okay, so this is the blank, and then identify, they are saying, therefore X is beta particle. Don't say beta radiation. Alright, alpha is a particle, beta is a particle, but gamma is a radiation. X is identified allowed to pass through a 2 mm thick aluminium block in which the mass of the lead is embedded. Shadow of the block is produced on the fluorescent screen around
Placed beyond the block.
beyond the block. The shadow of aluminium is fainter than the shadow of lead. Explain. Now here, in order to get the clearer picture, some of you will have a little problem. So this is your aluminium and this is the lead. Okay, and the radioactive source. Okay, so the X, that means beta radiations are allowed to go here. Now on the shadow that is there, I will see and I will see like this. Did you understand this? This will be the darker shadow and this will be the faint shadow. Who can tell what it is? The reason?
Lead and aluminium is lighter because
No, they are saying explain. They are not telling you identify. They are telling you
The
explain.
particle causes fluorescence.
Where fluorescence you are seeing?
because
Aluminium causes fluorescence.
lead does
When
not-
there is fluorescence, you see shadow.
Sorry.
lead
See,
is-
shadow is not because of the fluorescence. Now, in order to understand, you tell me, if you stand and this is the sun, we will see the shadow here.
Yes.
Yes, ma'am.
Why do I see the shadow? Because the rays of the sun are blocked here.
Yes, ma'am.
So, all of you forgot to mention that something is blocking these beta. Completely blocked, so dark shadow. Partially allowed to go, so faint shadow. Did you understand that?
Yes, ma'am.
Yes,
So
ma'am.
what you have to see, you have to talk about the penetrating power. So this shadow is to be linked by penetrating power. Not even one of you said penetrating power. Correct or no? Yeah. So, so what you will say that the beta particles are uh, completely stopped by lead. By lead mass. Correct or no? Completely stopped by lead mass, comma, forming dark underline, completely stopped by lead, forming dark shadow. Correct?
Yes, ma'am.
This is the first point. The second bullet, tell me, I'm not writing. You tell me what you should write.
The beta particle are partially
Huh.
stopped.
Or you can say, just say they. You can start with they. They are
partially stopped.
Partially stopped or partially allowed to go through. Partially. They partially penetrate through. Aluminium block, forming
Do we need to mention
faint shadow. And then in the last line, this is because beta particle can penetrate partially through aluminium but cannot penetrate through lead. Okay, this will be written here after this. All right. Observe the circuit diagram. You'll have to draw the circuit diagram. So when you draw the circuit diagram, show a triangle like this way. Oops, there should be ammeter here and the plug key here. Then you show this. Call this as A, call this as B, call this as D, call this as E, call this as C, and just put zigzag like this, because nobody is going to give you marks for drawing the diagram. Okay, so this is your, oh my goodness, this is R1. R1 equal to 3 ohm. R2 also is 3 ohm. R3 also is 3 ohm. Okay, now R4 is this. This is R4, this is 0.5. 0.5, and this is R5, which is 0.5 ohm. You finished?
Yes.
What are they asking you? Equivalent resistance. B is ammeter reading. And C is current through I through R3, which is 3 ohm. There is, I just want to know if there is a fourth. No. All right. How do you start with equivalent resistance? To begin with, you'll have to start from this part. Okay, now in your diagram, draw this, and this is, can you see one path? So this will be your
RS1.
RS1, very good. Now this RS1 and this, there are two
RP.
branches from here. Can you see that two branches? That means this is RP. Understood?
Yes, sir.
Now this RP is going to be with this. So ultimately, what are you going to have? You are going to, if you are getting confused, you will just show this, okay, and then you will show this. This is your D and this is your E, and this is going to become your RP, which is the combination of this whole thing. Okay, this is RP, and this is your A and B. Now the current is going to go this way, come this way and this way. Means this and this, they are in series. Okay, so I'm going to show this way, and this way. This is my RS2. Understanding?
Yes, ma'am.
Excuse me, I took this and I took this. I took this. What did you do? Understood? Yes, ma'am.
Yes, ma'am. Sorry, ma'am.
But in your diagram, it is saying no, ma'am. You broke the circuit and you took like this. You can't do that.
Yes, ma'am. Sorry, ma'am.
All right?
Yes, ma'am.
How do we start? Now this, because R1, R2 are given, we'll have to mention R1 and R2 are in series. I know y'all don't like to write the statements, but please write. Therefore, RS1 equal to R1 plus
R1
R2,
plus R2.
which will be 3 plus 3,
3
which
plus
is
3.
equal to 6 ohm.
6 ohm.
Okay, then what you'll say, RS1 and R3 are in
R in parallel.
parallel. Now, even if you write parallel like this, not a problem. Nobody's going to cut your marks, but write it. Okay, therefore, what you'll say, 1 upon RP
1 upon RP
is equal to 1 upon RS1
RS
plus 1 upon
Plus 1 upon
R3.
RS2.
RS2 kahega R3, no?
Yes, ma'am.
So that will be 1 upon
1 upon
6
6
plus
plus
1
6
upon
plus 1 upon
3.
3.
How much is that? This is 1
3
plus
by
2.
1 plus
So
2.
3 upon 6,
which is
3 by
equal
which
to
is 1
by
upon 2.
Therefore,
Now,
1 by RP is equal to
RP is equal.
Therefore, RP. Don't write equal to 2. The moment you write equal to 2, your teacher will give you 0. Because half a lakh is not equal to 2 lakh. If you have to give somebody half a lakh, would you give 2 lakhs instead? No, no. So remember that. So RP is 2. Now this RP and this, which one? R4. So what you'll say, R4, RP
R4, RP
and
R5
R5 are in
are in
current series.
Please everybody write this, and you are going to send me the images on WhatsApp group. Okay, so they are in series. Therefore RS2, which is the equivalent resistance, correct? And that is equal to R4 plus RP
RP
plus R5. Okay, so that is equal to R4 is
0.5.
0.5 plus 2 plus
2 plus
0.5. How much is it? 2 plus 1, that is 3 ohm. Okay, so this is your answer A. You're with me?
Yes. Yes,
Now find the ammeter reading. So for B part, Ammeter reading means the current in the circuit.
Current.
है ना? So right over there, ammeter reading is equal to I in circuit, which will be equal to, in the margin, if you get confused, write V is equal to IR. So I will be equal to V upon R.
V by R.
How much is V over here? 3 volt
3.
upon 3 ohm.
3 ohm.
Can you see over here? Check, internal resistance is not given. Correct?
Yes.
That means internal resistance we are not going to take into
1
account.
ampere.
So 1 ampere is your answer B. Correct? Underline that, underline that. Now the current flowing through R3. Now for R3, remember your R3 is in parallel circuit. Can you see that? So I have to get between D and E, what is the PD? So in your C part, I think I'll just change the color of the ink so that you will not get confused. For your C part, I think I will, where shall I write C part? I need space, so I shall create space. Can I create space here?
Yes, ma'am.
This is, yeah. Okay. So for our C part, anytime you have a parallel circuit and you have to find the current, your step 1 is going to be to find PD across parallel circuit, which means PD across DE. This is your DE only, no? This is,
Yes.
which is VP. Now V is equal to IR, so it will be IRP. Understood? What is I? 1 ampere. What is RP? 2. So how much VP is? 2 volt. Are you with me?
Yes.
Then your second step will be I through 3 ohm will be equal to, let us say, I1, and that will be equal to VP upon R3. How much is VP? 2 volt. How much is R3? 3 ohm. So that will be 0.66, recurring means 67 ampere. Okay, just to let you know that if it is 2/3 as I1 in this branch, it will be 1/3. So 2/3 here and 1/3 here. Total it will be 1 ampere.
Yes, ma'am.
Understanding? Yeah. So all of you are clear about this?
Yes, ma'am.
Question number 9. This was one of the, I think, competency based or sample paper.
Ma'am, it's also a solved example.
It is solved example in the book, no?
Yes, ma'am.
Is it exactly the same one?
No, ma'am.
Direction is changed.
Direction is changed.
Yes.
Yes, ma'am. Direction is changed.
What is the page number?
Yes, 7.
7.
So,
7. I think
solved example, Ray, they are saying.
this is
Solved example. No, this is different. No. What you have in the book is different. This was, there was a bag by Sumit and somebody like that. One is hanging on that wheel like this, the other one like that. This was one of the questions we have from ICSE Council. So it is based on this. They are suspended from P and Q point of the wheel that is pivoted at O, and the wheel is in equilibrium. What does equilibrium mean? That if this is W1, you'll have to show this diagram and call this as L1 and call this as L2. Understanding? Okay. Then what you'll say at equilibrium. we will have the sum of,
Anti-clockwise.
see, it will be this way, the moment for each one of them. Sum of this will be anti-clockwise, so I'm just writing equal to sum of
Clockwise movement.
clockwise moment. Okay, so it will be W1 L1 here equal to W2 L2 here. Now they have not given any measures, so if they ask you which one is heavier, then we'll write it W1 upon W2. So W2 has gone this side, so on the right L2 is remaining,
L2 upon L1.
and L1 will come this side. Okay, now L2 and L1, can you see L2 is greater than L1? At least you know this much.
Yes.
Yes, ma'am. Yes,
That means numerator is bigger, so what you'll say, therefore W1 is greater than W2. So which one is heavier?
Therefore,
W1.
W1 is heavier.
W1 is heavier as it is suspended from lesser distance
Then Q.
from the pivot. Correct or no?
Yes.
Than W2. W1 heavier. Okay, lesser distance from pivot. All right, so this was agreeable.
Yes.
Write the mathematical relation based on principle of moments that can be used to find W1. So we come to P based on the principle of moment. Now, did we write over here principle of moments? No. So we'll say by principle of moments, because if they tell you principle of moments, they have to see that word, no?
Yes.
Principle of moments.
At equilibrium.
No. Now let us write directly this one, because we already written all this.
Yes.
W2 L2. So W1,
They have given
There's only
W2
W,
is
so W2, so W1 into L1.
W2 is 15, no?
Yes.
Huh.
Yes.
So
15
W1
equals to-
L1 is equal to 15 kgf into L2. So they are saying find what?
right. The
W.
mathematics.
W1. W1 is equal to L2 upon L1 multiplied by 15. I'll put the bracket here because this is looking as though it's in the denominator. I cannot write anything more. They should have given some numbers here, then we could have calculated. Okay?
Yes.
Yes, ma'am.
Solid of mass 20 gram initially at 60 degrees is heated. Graph shows what is the state of matter indicated by part BC. So BC, where is BC? Here. Now tell me, this is a solid. So this will be solid here and the solid melts, correct?
Yes.
Yes, ma'am.
So melting begins here and melting ends here. And this part is going to be the liquid state. You're with me?
Yes, ma'am.
What is the state of matter indicated by BC? BC,
It's melting. The melting solid.
state of matter. BC represents solid melting into liquid
Without changing temperature.
at 160 degrees C. See, if the graph is there, we'll just supply the exact information.
Yes.
Okay, so 160 becomes the melting point. Duh. B, what you'll say, melting point is how much? 160 degrees C. Okay. Answer B. What is C? Calculate SHC SLHF. Okay. So using BC, you will say that heat, that is Q, is equal to MLF. Correct? How much is the heat for this region? This is 1500. Wait. 1, 2, 3, 4, 5. Can you see that? So 500. So this is your, each one is 100, 100, 100. Okay, so from here to here is 300. Are you able to understand?
Yes, ma'am.
Ma'am, that is 3000.
Yes, ma'am.
Which one?
It'll be 300 for each one.
1500 to 3000.
This is 3000.
Yes, ma'am. It'll
So 1500 this is, no?
Yes, ma'am.
1500, sorry. So we have 1500 divided by 5 is 300. So there are 3 divisions here. So from here to here is 3 3s 900. Correct?
Yes.
So this point over here is 2400. Correct? And this will be, again this is 1 2 3, no? So 4500 plus 900. So 5400. Correct? So what is the value of Q? It is 5400 minus 2400. Correct? Is equal to, mass is 20 grams they have given. So it will be 20 grams. This is joules multiplied by LF. How much is it? 3000, right?
Yes, ma'am.
So LF is equal to 3000 joules upon 20 gram.
150.
150. So specific latent heat of fusion of solid is equal to 150 joule per gram. All right.
Yes.
Now they could have also asked right over there a question which they have not asked. They could have asked you to find SHC of solid also. If they had to ask you SHC of solid, what would you have done?
MC delta.
I'm sorry, delta.
Ha. So what you will say, using AB. Yeah. Q is equal to MC delta T. How much is Q from here to here?
22.
This was 2400, right?
Yes, ma'am.
So from here to here, it will be 2400
minus
is equal to those many joules minus what?
60, ma'am. Because it starts at.
No, this is
Sorry.
this
Yes,
is
ma'am.
20 40 60, but this is 0 from this.
Yes, ma'am. Sorry.
This is 1500, this is 3000, no?
Yes, ma'am. Sorry.
So this is 0. So this point is actually excuse me. Understood?
Yes, ma'am.
Yes, ma'am.
So mass will be 20 gram into C, and how much is delta T?
100.
100. Correct?
Yes.
So C will be equal to 2400 joules upon 20 gram into 100 Kelvin, I'm saying, rather than degree C.
It will be 12 joule per gram per Kelvin.
How 12 ray?
Yes, ma'am.
1.2.
1.2.
Correct?
Yes, ma'am.
Ma'am, Ma'am, they have given the temperature in degrees Celsius.
Yeah, but delta T is 100 degrees C or 100 Kelvin, no?
Yes,
Delta T 1 degree C is equal to 1 Kelvin.
Yes.
Delta T will be the same in degree C and Kelvin, okay?
Yes.
I mean, I cannot say 160 Kelvin. It will be 160 plus 273 Kelvin. And this is 60 plus 273 Kelvin. But when I take the difference, that 273 will get cancelled, no?
Yes, ma'am.
Okay. So remember your delta T which is equal to 1 degree C will be the same as 1 Kelvin. Remember that. Delta T, change in temperature, will be the same in degree Celsius and Kelvin scale also. Everybody understood how to handle this?
Yes, yes.
Okay, supposing this was like this, okay, and this was given over here, okay, then you would be able to find, even from this part you can find SHC of the solid, then liquid, no? SHC
Yes,
of liquid also you can find using this and this, understanding?
Yes, ma'am.
Okay,
Yes,
but
ma'am.
they are not giving you the number, so let's move on to the next one. Is this the solved question? Is this the solved question? Look fast. Now instead of the, I think in the textbook the magnet is dropped. Magnet is dropped, and here the coil is brought closer.
Yes, ma'am.
है ना?
It's on page 272.
272. Are they having the same thing state? In which direction the current flows, A to B or
Yes, ma'am.
B to A? It's the same one, right?
Yes, ma'am.
Magnet is dropped and the coil. Now here it is ulta. Now here they have given the mirror image of this thing. Can you see that?
Yes, ma'am. Yes.
Huh. So here, if the coil is coming down, then north pole, this north pole is coming closer kind of to the coil, correct? When you bring the coil closer, north pole is coming closer, yes or no?
Yes.
So north pole will be over here and south. So can you just show the diagram? Now to draw this diagram, some of you may have a little problem. So see, it is over and under. Can you see that over and under?
Yes.
Now don't put rings over there. Just pull the wire like this and push it like that. Pull the wire from here and push it like that. Pull the wire from here and push it like that. And then it will come from under the core.
Yes.
And this, my goodness, which is A and which is B?
A is the top one. And
Top
B
is A, no?
Yes.
A and B. Because of this pointed structure, you thought, no? Yeah.
They've given it in different direction, A and B.
Oh, it is given sleeping, no?
Yes.
A is written like this. Oh, yeah. Why would they do that? Oh, here also they've given like this. Hai na? Oh. Okay. They must have had the diagram like this, and they must have rotated it and made it like this. That is why they couldn't change that. We understand. You tried to copy, paste. Okay. So you finished drawing this. Everybody understood how to draw the turns.
Yes, ma'am.
Now this is going to be north, means it has to be anti-clockwise. Now anti-clockwise will be like this and the clockwise will be like this, correct? Now if it is anti-clockwise, it will go over and under. Does it make sense to you?
Yes, ma'am. Yes, ma'am.
It will go B to A.
Very good. Here only the understanding part is important. Otherwise, your answer is just B to A. Is it not so?
Yes.
Otherwise, you don't have to do anything. Name the law used to come to your conclusion. So use Lenz's law. Lenz's law, and also we use the clock rule.
Ma'am, oh, okay.
Because clock is the rule, not the law.
Yes, ma'am.
Yes, ma'am.
Okay. Name the law. So we named the law. If they say state the law, then name it and state it also.
Yes,
Yes, ma'am.
Did you understand?
Yes, ma'am.
What is the magnitude of the current when the coil is stationary?
0.
If the coil is stationary, it will be 0. Right over there, since no change in
Magnetic flux.
mag flux. If the number of turns is doubled, what will happen?
It will also double.
Induced current doubles since induced current directly proportional to number of turns. And that finishes the paper. How was it? Good, bad, or ugly?
Good.